Assalamu alaikum and hi everyone. My name is Rusyidah binti Boestami from Politeknik Sultan Idris Shah. We stand at a critical intersection of global challenges, rising fuel costs, climate change, and the persistent problem of waste management. Our reliance on conventional petroleum fuels not only drives global warming and increases greenhouse gases, GHG, but also contributes to public health issues like respiratory ailments due to harmful combustion byproducts. Simultaneously, we face an environmental burden created by massive quantities of discarded materials, such as used cooking oil and chicken eggshells, which represent both environmental waste and economic loss. This research, titled Green Valorization of Waste, Biodiesel Production from WCO using chicken eggshell-derived catalysts, addresses these interconnected issues head-on. Our core innovation centers on applying principles of the circular economy, a sustainable approach that maximizes resource use and promotes recycling, to create cleaner, more sustainable energy. By transforming two common waste streams, we aim to align directly with Sustainable Development Goals, SDGs, 7, affordable and clean energy, 12, responsible consumption and production, and 13, climate action. Traditional biodiesel production relies heavily on the transesterification process, typically utilizing homogeneous catalysts such as sodium hydroxide, NaOH, or potassium hydroxide, CO. While effective, these conventional chemicals pose significant operational and environmental hurdles. Specifically, when dealing with waste cooking oil, WCO, the high free fatty acid content causes these catalysts to induce soap formation, saponification, which complicates the final product separation and creates vast wastewater streams. Our innovation replaces these problematic chemicals with a sustainable, heterogeneous catalyst derived from an abundant bio-waste, chicken eggshells. Eggshells primarily consist of calcium carbonate cacao, which can be easily converted into highly active calcium oxide, SO, a highly stable and reusable catalyst. This strategy represents a dual waste utilization approach, simultaneously repurposing WCO and discarded eggshells, thereby minimizing environmental pollution and supporting zero waste objectives. The production process is twofold: catalyst preparation and transesterification optimization. To prepare our green catalyst, waste chicken eggshells undergo a comprehensive treatment: washing, drying, and finally, calcination. The eggshells were calcined in a muffle furnace at 900 Celsius for 4 hours, successfully converting the initial calcium carbonate, cacao, into the active catalyst, predominantly calcium oxide, SO. Once the catalyst was prepared, we filtered the WCO to remove impurities and proceeded to the transesterification reaction. This step involved mixing the filtered WCO with methanol and our eggshell-derived SO catalyst. We optimized key reaction parameters, including the methanol to oil molar ratio and the amount of catalyst loading. Our studies established optimal conditions that delivered exceptional results: a 12:1 methanol to oil molar ratio combined with 5 grams of the prepared catalyst. The effectiveness of our process was rigorously validated using advanced analytical instruments. To confirm the successful catalyst conversion, Fourier-transform infrared (FTIR) spectroscopy was employed. The FTIR spectra confirmed the presence of SO, specifically showing absorption peaks around 3,640 cm1, which indicates the successful removal of carbon dioxide from the precursor cacao. Under optimal conditions, the experimental reaction achieved an impressive biodiesel yield of approximately 97.46%. Next, the quality of the resulting biodiesel was validated using gas chromatography-flame ionization detector (GC-FID) analysis. This analysis identified and quantified the essential fatty acid methyl ester (FAME) components, such as C16-0, 217.5 mg per liter, and C18-0, 97.47 mg per liter. Crucially, the resulting biodiesel was characterized and found to comply with major international fuel quality standards, including the American ASTM D6751 and European N14214 specifications, ensuring its suitability for satisfactory operation in diesel engines. The novelty of this study lies in its commitment to sustainable green chemistry. We have confirmed that calcined chicken eggshell-derived SO is a highly functional, reusable, and low-cost heterogeneous catalyst. The catalyst retains substantial activity even after 3 cycles of use. The findings point toward significant commercial viability. By utilizing low-cost feedstock, waste cooking oil and repurposing eggshell waste, we substantially minimize production costs. This cost-effectiveness allows the resulting biodiesel to compete economically with conventional petroleum diesel. Beyond economics, the product offers a clear environmental advantage. Biodiesel is biodegradable, non-toxic, and burns cleaner, reducing emissions of carbon monoxide and particulates compared to traditional diesel. This product was registered in my IPO for copyright products in notification number CRLY 2025W03834. In conclusion, this research successfully validated a cost-effective and sustainable method for biofuel production. The synthesized SAO heterogeneous catalyst is inferred to have an enormous capacity for large-scale, low-cost WCO biodiesel processing to meet future renewable energy needs. We have demonstrated a practical, scalable, and eco-friendly alternative to conventional methods, building a more sustainable future through the circular economy. Thank you for your attention.